Hello everyone, welcome to the class of Introduction to Finance. Today let's continue with Chapter 7, and this is going to be the second class of Chapter 7. So today we plan to discuss the bond valuation and yield to maturity. Let's first discuss bond valuation. So in this slide we see what is the opportunity cost of debt capital, and in order to value a bond, to price a bond, basically that is the same as calculating the fair price of the bond, right? And from chapter 5 we already know that to calculate the fair price of the bond, that is the same as calculating the present value of the bond given all the future cash flows, right? So basically that's just calculating the PV. Then in order to calculate the PV, we will have to know all the other informations, including N, which is the number of period, and I/Y, which is the yield or the interest rate for that period. And then we also need to know PMT, which is the payment of that period, and also the future value, right? So the interest rate of that period is an important input to calculate the fair price of the bond. So therefore we need to know what is the appropriate interest rate we need to use, and that's basically the required rate of return for that bond. And from chapter 6, the one that we just finished, we know how to calculate the required rate of the bond given its characteristics, right? So basically it's the following equation. So chapter 5 provides us with the method, with the way to calculate, to price a bond, and chapter 6 provides an important method to calculate one of the important input, which is the required rate of return, the interest rate of that period. So using this equation, we will be able to calculate the required rate of return for the bond, and which is the same as the discount rate, as the opportunity cost of the capital, and is also the rate that could be earned on alternative investments of equal risk, right? So that means we need to know the maturity of the bond, the default risk, the liquidity risk, plus the inflation risk, and we calculate all these risk premiums plus the risk-free rate of return, and then we will be able to calculate the required rate of return. But that was the information or the material we discussed in chapter 6. So in this chapter, I'm not going to ask you to do the same thing again. In this chapter, we'll just assume that the required rate of return is always given. So this part you don't have to be worried about it. I'll give you the required rate of return, or sometimes I may ask you to calculate it backward, to calculate the required rate of return. But you should know that no matter whether I ask you to calculate backward or forward, you know the required rate of return is based on the following the listed factors. Yeah, that explains why the required rate of return is at a certain level. So this timeline here shows you the cash flows of a bond, and basically the value of the bond is the fair price you pay right now, right? So you pay this price, and then you will be able to earn all the future cash flows. Yeah, so that's the value of the financial assets. And if the required rate of return is R%, and then you receive all these cash flows from cash flow 1 to cash flow N in the end of each period. And the bond will last for an N period. So that's the number of period or due maturity. So in theory, you could use the following equation to calculate its fair price, to calculate its value. That's the same as discounting all the future cash flows, right? So basically all the numerators are the cash flows, and then you put in the discounting interest rate in the denominator, and then therefore you can calculate the value, the fair value of this bond. So R% is the market rate of interest on the bond, not the coupon rate. The coupon rate determines the cash flow in each period, but not the market interest rate. But this market interest rate is equal to the coupon rate at times, especially the day the bond is issued. So usually on the issue day, the required rate of return is the same as the coupon rate. And then if that happens, when these two rates are equal, the bond sells at par. Yeah, so basically the market, based on those liquidity risk premiums, default risk premiums, inflation premiums, I calculated this should be my required rate of return. And I use this required rate of return to determine my coupon interest rate. And then I issue the bond with this coupon interest rate. That basically determines that my bond will be sold at par. And N is the number of years to maturity if the payment occurs annually. If it doesn't occur annually, if it occurs semi-annually, then N is N should be the number of years divided by 2, right? Oh, sorry, N should be the number of years times 2. Yeah, and CF is the cash flow, is the periodic interest payments, and would be 0 for zero coupon bond. Okay, so now let's have a look at the bond valuation. So this is an example question. What is the value of a 10-year 10% annual coupon bond if the discounting interest rate is 10% and the face value is $1,000? So we can draw a timeline of this cash flow like this. We're trying to calculate the fair price at the current moment, right? And the market interest rate is 10%. The cash flow in the end of each period is $100, which means if the face value is $1,000, then that means the coupon interest rate is also 10%, right? So this is a coincidence that the coupon interest rate is exactly the same as the market interest rate, right? So in this case, you actually don't even need to use financial calculator. When these two equal, the fair price of the bond always equal to the face value. Yeah, you actually, if you want, you can use the following equation, but you actually don't need to use this. You can just know that the fair price of the bond equals to its face value. Okay, and this one is using the financial calculator how to do it. So you can see that the bond has $1,000 lump sum, the par value due at maturity, t equal to 10, and the annual $100 coupon payments beginning at t equal to 1 and continuing through t equal to 10. The price of the bond can be found by solving for the present value of these cash flows. So you see n equal to 10. The interest rate is also 10. That's the market interest rate, which is the same as the coupon interest rate because the payment is also $100 and face value is $1,000. So what is the fair present value? That's negative $1,000. So in this chapter, you have to be extra careful that with the signs, because basically the payment is not going to be 0 in most cases unless it's 0 coupon bond. Otherwise, you always have payment. And when payment is non-zero, these two are not always the opposite sign, which means you have to be very careful with the signs. Otherwise, you may get the wrong answer. Maybe I'll give you a better example later to show you the sign can really determine the result. Okay, so let's change the question a little bit. Here it says, what's the value of a 10-year bond outstanding with the same risk but a 13% annual coupon rate? Yeah, so this question is very similar. It's also asking for the calculation of the present value, the fair price, right? The value of the bond. And the same maturity, n equal to 10, and then same risk, so which means everything else is the same. The required rate of return is the same, right? So that means the market interest rate is 10%. but the coupon interest rate is 13%. So what does coupon interest rate affect? That directly affects the payment, right? That's the cash flow you receive every period, the interest income you receive every period, right? So if it's 13% coupon interest rate, then every year you should receive $130, right? So because the face value is $1,000 and it's annual, here it's not semi-annually compounding. Therefore, PMT equal to 130, FV equal to 1,000, N equal to 10, and market interest rate is the same as 10% because it's the same risk. Yeah, the risk is the same. That means it has the same yield to maturity as the previous bond, which is 10%. The only thing that has changed here is the coupon payment, $130. So therefore, we can calculate the PV. And in this case, after use financial calculator, you know the PV should be $1,184.34. Yeah, so this is the PV. And you see this one is higher than the one that we calculated before, the one with 10% coupon interest rate. So this one pays you higher coupon interest rate, which means you receive more payment every year. Therefore, it makes sense for you to pay higher price in the beginning in order to earn a higher interest income in the future, right? Given that you bear the same risk, right? So it makes sense that the present value is higher. Okay, then let's change the condition a little bit again to lower the coupon interest rate to 7%. Before it was in the previous question it was 13%, right? Now everything else is the same, but now it has reduced to 7%. So that means N is 10, I/Y is also 10 because it's the same risk. PMT now becomes 70 because coupon interest rate is 70 and future value is still $1,000. So for the same risk you bear, you now receive less interest income every year. Therefore, it makes sense for you to pay less for this bond, right? So therefore, if you use financial calculator, you'll see that the present value now has declined to below the face value. Now it's $800, $815.66. So this is the fair price value. So based on these three examples, what can you see from these three examples? You might realize one thing, that if the market interest rate RD, D represent discounting, so that means this is the market yield. If the market interest rate equal to the coupon interest rate, then in this case the fixed rate bond will be selling at par. Therefore, it's a par bond. Remember, what does par mean? Par is the face value, right? So in this case, PV will be equal to FV, will be equal to $1,000 if the market interest rate is exactly the same as the coupon interest rate. Yeah, so that means you pay the face value to get this bond, right? Or it's a bit like, you can look at it as essentially this is a loan, right? So you pay the interest rate that you deserve, the market interest rate, then that means you get the face value right now, and in the future when the loan matures, you pay back the face value. But in between you have to pay interest. And the bank gives you the interest rate that you deserve based on your income, your asset, everything included. The bank gives you your market interest rate. So if you pay that market interest rate right now, the price of the loan for you is exactly the same as the face value. So this is basically the same as par bond. If the coupon interest rate is exactly the same as your the bond's market interest rate, which means the bond is going to pay interest exactly the same as its market interest rate determines, or its required rate of return, right? In this case, no one is taking advantage of the other, and then the bond should be selling at its face value. or par value. But if the coupon interest rate is lower than the market interest rate, in this case, the bond should be selling at below its par value. What does it mean? It means that based on the current market situation, if you want to go to the bank and borrow, you should pay at least, let's say, 7% interest rate, because right now the interest rate is quite high, right? So if you want to go to the bank to borrow money to buy a house, let's say a mortgage loan, your market interest rate is 7%. But you are telling the bank, no, 7% is too high. I don't want to pay 7%. Then in this case, you're not going to get the loan, right? But let's say, suppose the bank is still willing to do this business with you. You say 7% is too high. I don't want to pay 7%. Then the bank might be saying, okay, if you think 7% is too high for you, but this is your current market interest rate. So if you want to pay a lower interest rate, then in this case, what would the bank do? You say that I only want to pay 5%, then in this case, the bank will have to kind of lend you less money, right? So that will be, you want to borrow, let's say, $1 million to buy a house. The bank is like, okay, since you only want to pay 5%, then I'll only give you, like, let's say $500,000, but in the end you have to pay back $1 million. Yeah, so the bank is giving you less to compensate for the lower or fewer interest income you pay back to the bank, and vice versa. If you are willing to pay higher interest rate, so when the coupon interest rate is higher than the market interest rate, then this bond should be selling above the par, which means you say let's say your market interest rate is 7%, but you're telling the bank, no, I want to pay higher. I want to pay 10%. The bank, of course, will be willing to do this business with you, but to make it fair, you have to, because you're paying higher than you should be paying in the future, therefore the bank should give you more money right now, and in the end you still pay back the same amount, the face value of the bond. Yeah, so that means the bond is selling at a premium. So this slide is actually very, very important. I forgot to highlight it. I'm going to do it later, but it is very important that you understand this part. When the market interest rate equals the coupon rate, the bond is selling at a par. When the market interest rate is higher than the coupon interest rate, the bond is going to be selling at a premium. And when the market interest rate is when the coupon interest rate is higher than the market interest rate, then the bond is selling at a premium. When the coupon interest rate is lower than the market interest rate, the bond is going to be selling at a discount. Yeah, so this is bond valuation. This graph here shows you the change in bond value over time. So it's actually in line with what we just discussed in the previous slide. Remember, there are three types of bond. If the market interest rate is the same as the coupon interest rate, then the bond is selling at par. So let's see, if the face value is $1,000, then this is the value of the bond, right? And then in this graph, the vertical line is the value of the bond, the horizontal line is the years to maturity. So let's see, the coupon interest rate is something that you determine. Is determined on the issue date, right? And it will never change. But the market interest rate can change because of the Federal Reserve's policy, the market conditions, financial crisis, whatever. It keeps changing, right? It's basically determined by the demand and supply of the money in the market. So, but let's assume if the market interest rate remains at 10%, the same as the coupon interest rate all the time, yeah, for all these 10 years, then there's basically no change in the price of the bond over time. It will always be at $1,000. The bond will be selling at exactly its face value all the time. Yeah, but let's see, if the market interest rate is 10% and the coupon interest rate is 13%, Yeah, so that then we calculated the fair price of this bond should be 1184, right? From based on the previous slide. So $1184. So that's the fair price of the bond. And let's assume the market interest rate doesn't change for the 10 years, for the duration of the bond before it matures. Then the price of the bond is going to gradually decline until the last day of its maturity, and then it will reach $1,000, the face value, on the day of maturity. Yeah, so it's going to decline and converge to the face value on the last day of the maturity. And it's the same for this discount bond. If the interest rate, coupon interest rate is only 7%, the fair price of the bond right now is 816, right? So also from this calculation, right, it's 816. But the price of the bond is going to increase slowly until the maturity date. It will also converge at $1,000. And why is that? Basically, you can just calculate the present value at any given time in this graph, right? We calculated when it has 10 years to mature. You can change the n to 9, to 8, to 7, to 6, and then you can calculate the present value for this bond at every year, right? Then you can draw this figure or graph yourself, and you will notice this trend. But it's important that you know how to draw this graph, or you know how to calculate the present value of this bond, but it's also very important for you to understand why it is the case. The key thing, or the main logic behind this graph, behind this trend, is that let's assume tomorrow is the maturity date. No matter whether the bond initially promised 13% coupon interest rate or 7% coupon interest rate, given that tomorrow is the maturity date and the bond will pay back the face value on its maturity date. Let's just assume that they have paid all the interest payments already. So there's only one cash flow that is left tomorrow, is the face value. So no matter how high the coupon interest rate it was before, it doesn't matter anymore, because tomorrow or the next day you're going to receive the face value, right? So that's why all bonds all converge to its face value, no matter whether initially it was selling at a premium or selling at a par. Yeah, so they will all converge to its face value, because the next day, that's the cash flow the investor is going to receive. Yeah, the difference is where it started from. So if it's higher coupon interest rate, the bond was selling at a premium, then it will the value of the bond is going to decline slowly till its maturity date. And then if it was discount bond, then the value of the bond is going to be increasing slowly to its face value till maturity date. But again, this is like this curves is very smooth, and it basically never happens in reality, because here the assumption is that the market interest rate doesn't change for the whole duration of the bond. So that basically means that market interest rate doesn't change for 10 years, which never happens, right? Market interest rate actually changes pretty frequently. So this is just a theoretical how to say, conclusion. It doesn't really exist, but it should, theoretically it should have this trend. And even if the market interest rate changes all the time, you'll see ups and downs along this curve, but the general trend should still be like this. Yeah, because no matter what, if tomorrow is the maturity date, then you're going to receive the face value the next day, and therefore the value of the bond should all converge to its face value as it approaches its maturity date, right? So that's the logic behind this behind this graph, and this graph is also important. I'll highlight it later. So basically, this is a summary of what it shows in that graph. So at maturity, the value of any bond must equal its par value. And if the market interest rate, if the discount interest rate remains constant, then the value of a premium bond would decrease over time until it reaches its face value, $1,000. And the value of a discount bond would increase over time until it reaches its face value, $1,000. And the value of a par bond stays at $1,000. So here's an exercise question. This company's bond mature in 8 years, have a par value of $1,000 and make annual coupon interest payments of $65. The market requires an interest rate of 6.1% on this bond. What is the bond price? This is a very typical question of a bond valuation, right? It's asking what should be the bond fair price. So it's asking what is the present value of this bond. Then we basically have to find all the other 4 inputs, right? So clearly the FV is going to be the par value, $1,000. And then the PMT here is, he already told you the annual coupon interest rate is 65. So PMT is 65. N is 8, right? Mature in 8 years. And the market interest rate right now is 6.1 for this bond. Therefore, we just need to put in all those information. N equal to 8, interest rate equal to 6.1, PMT is 65, FV is $1,000. Then you can calculate the PV. That's $1,024.74. So the correct answer should be A. Yeah, this is bond valuation. Next, let's discuss how to calculate the yield of a bond. There are actually 2 types of yields, yield to maturity and yield to call, determining on how long you're going to hold this bond, to maturity or till the company calls back the bond. But today we're only going to discuss one, that is yield to maturity, which is actually also easier to understand. So the yield to maturity actually, what does it mean? Means that's the rate of interest you earn on your investment if you bought the bond, held it to maturity, and received the promised interest payments and maturity value. Yeah, so that's basically the interest rate you will get. Assume you hold the bond to maturity, right? That's what the name suggests, yield to maturity. So you hold it to maturity and you receive all the promised cash flows, including the interest payments and the face value in the end. And then your final rate of return will be the yield to maturity. So then basically what is essentially yield to maturity? That's just the interest rate, the interest, the I/Y that we calculate using the financial calculator. Assume that N is the number of years to maturity, and then payment is the interest payment you receive every year, and then the face value will be the future value will be the face value in the end, right? Because you are going to hold it till maturity. So in the end, you're going to receive the face value. And then you bought the bond at a certain price. You pay the price for the bond, which is the present value. So in this case, if you put in all the input for the 4 variables, then the I/Y is going to be the yield to maturity. Yeah, that's the rate of interest you earn on your investment, right? So that's the discounting rate that solves this model, solves this question. So here's an example question. It's a 10-year bond, 9% annual coupon. So this 9% we'll use it to calculate the payment. $1,000 par value. This is the future value. Selling for $887. So this is the present value. But be very careful. This is what I meant. You have to be very careful with the signs. So this bond is selling for $887, which means this is the price you pay. Therefore, this for you is going to be cash outflow. So you have to be put a negative sign in front of it, right? While the par value or the face value, this $1,000 is the value you're going to receive in the end of the maturity. Suppose you're the investor, right? So you pay $887 negative because this is cash outflow. and you receive $1,000 in the end, positive. This is the cash inflow, and you're going to receive interest income too, which is 9%, so that's $90 every year, right? So this is also positive because for you it's going to be cash inflow, right? And then you put in all this input, you calculate the I/Y, which is the yield to maturity. So this is solving for yield to maturity. So you see n equal to 10, present value is negative $887, PMT is $90 positive, future value is $1,000 positive, and then you receive the interest, the required rate of the rate of return is 10.91. So that's the yield to maturity. Yeah, and because you notice that even if before you do this calculation, you can actually roughly guess whether this yield to maturity is going to be higher than the coupon interest rate or lower than the coupon interest rate based on the relationship between the price and the par value, right? So here the price is below the par value, which means this bond is selling at a discount. Why would the bond be selling at a discount? It's because the coupon interest rate is lower than the market interest rate, than the required rate of return, right? And the coupon interest rate is 9%. So for sure, this interest rate that you calculated, the result must be higher than 9%. Yeah, that's why the bond is selling at a discount, because the yield to maturity has to be higher than the coupon interest rate. So here is actually one way for you to check whether your result is correct or not. But again, be very careful. This price has to be negative. If you put in positive here, the calculator will give you either say no solution or error, depending on what type of financial calculator you use. Yeah, so this one has to be negative. And payment and face value has to be both positive. If you mix up the signs, let's say face value positive, future value positive, present value positive, interest in payment you put it negative, you are going to get a result. But I don't know how that would be. For sure it's going to be the wrong result. So again, be very careful with the signs here. And here's also an exercise question. Find the yield to maturity if the bond price is $1,134.20. So here, solving for the yield to maturity, solving for the interest rate. The yield to maturity of this bond should be 7.08%. How do you get this result? Putting n equal to 10, which is the same. Everything is the same, except for the price, right? Payment is still $90. Face value is still, future value is still $1,000. Present value in this case is negative $1,134.20. Yeah, and then if you calculate the yield to maturity, now you'll get the result of 7.08. Why is it? It's because in this case the bond is selling at a premium, because the price is higher than the future value, right? Therefore, that means the market interest rate must be lower than the coupon interest rate. So the result must be lower than 9%, and the result is 7.08%. Yeah, so here's again, inconsistent with what we just said before, a way for you to check whether the result is correct or not. Here is an exercise question. It asks, a treasury bond has an 8% annual coupon and a 7.5% yield to maturity. Which of the following statement is correct? So notice that this is a treasury bond, and the coupon interest rate is 8%. The yield to maturity is 7.5%. So the coupon interest rate is higher than the yield to maturity, which is essentially the required rate of return. So what does it mean? You get higher interest income than you deserve. Therefore, the bond is going to be selling at a premium, right? So that means we rule out basically A, because here it says the bond is selling at a price below par. So that means the bond is selling at a discount. B says the bond has a current yield greater than 8%. That's wrong, because the yield to maturity is 7.5%. so it's not higher than 8%. C, the bond is sells at a discount, which is also wrong because it's the same as A, right? Price below the par means it's discount, but clearly this bond should be selling at a premium because the coupon interest rate is higher than the yield to maturity. D says the bond's required rate of return is less than 7.5%, which is wrong because the yield to maturity is exactly 7.5%, so it's not less, it's the same. E says if the yield to maturity remains constant, the price of the bond will decline over time. Yeah, here it says if the market interest rate remains constant. That's the first assumption, right? Remember the graph we saw before? The key thing here is that market interest rate has to stay the same. Otherwise, you will see the price keeps it's going to be volatile. So if the market interest rate remains constant and the bond is selling at a premium, therefore the price of the bond will decline over time until it converges to the face value, right? So E is correct because the bond is selling at a premium. Therefore, the price is going to go down over time if the market interest rate remains the same, which is the same as the yield to maturity. So the correct answer is E. Okay, so next topic is yield to call, but we'll leave this one for our next class. Thank you all for attending the class today. I'll see you next time.